Hi folks, this is Karim Raouf for IT Visualizer channel. We will continue our lab, the matrix lab. This is the video number 104. We have been discussing in the previous video the following. We have seen the case that was generated by Claude AI, which is a very complex and astonished case from my point of view. We have seen that he has created a scenario how we can fix some corrupted system files in the Windows. For example, the scenario was we have the accounting team, about 20 PC that is owned by the accounting team, and they have a problem in their Excel program after a recent Windows updates. We have seen how Claude have generated the scenario, and it was a little bit complex. We can see that he has already generated the script or how we can solve it using SFC, then DISM. Then after that, he has suggested if we need to use SFC and DISM in a virtual environment to see how or to test the repairs, and not actually the SFC and DISM, but he has also generated a complex script to monitor the repair process, okay, using process monitor. So it's a little bit not let's say it's not logic, but it seems to be a unique approach from my point of view. So we have seen that he has not already fixed the problem, but he is learning, or he's telling the junior IT how to monitor the process of the repair. What is the mechanism of the SFC and DISM for repairing? We have seen that he had generated a script to monitor the process of the repairing and repair the process itself, and he asked if you need to create a virtual environment to see this test, the monitoring and solving test in a virtual environment. We have seen how this scenario was evolving, or it was progressing, until we reached a time that it was very complex, and I asked him to generate a summary because the script is getting larger and the scenario is getting more complex. So at the end, I asked him to provide a summary for what we have done until now. So we have stopped the last time at this step. Let me show you what is the scenario exactly. So we have a scenario, okay, as we have seen before, that we have some infected machines or affected machines of the accounting, that their Excel sheet is not working. The Excel program is not working, so we are trying to fix that using SFC and DISM, and we are trying to monitor the whole process. Okay, so we have generated a script to do that, and he asked me to create a virtual environment that to test this script. We have in our virtual environment 3 virtual machines. The first virtual machine, it is our baseline. We install on it clean Windows installation. We have some performance baseline. We are making some measures, or we need to know or to differentiate between the normal performance of a machine and the performance of the machine when we are applying the SFC and DISM repairs. Will this affect the machine? So we are taking a normal machine, its baseline performance, we monitor normal usage, and then we are collect matrices, and then metrics, and then the second virtual machine, we will create a problem that will be solved by the SFC, and the third machine, we will create a problem that will be solved by the DISM utility. So we have stopped. We have seen this virtual machine. We have done a lot of things concerning this virtual machine. We have seen a script to create the performance baseline. We have seen a lot of things concerning the first virtual machine. We have a lot of details concerning this machine. And as the second virtual machine, we will begin now using our performance baseline matrices to apply them to our second virtual machine to see the difference between the normal usage metrics and the repair metrics. Okay, virtual machine, we have prepared the system, check dependencies, create backup, take a snapshot, create the issue, and then monitor the repair from the script that we have generated from the first virtual machine. So this is the scenario. Now we are working with the second virtual machine. All of our previous videos was working on the first virtual machine. If we go and see the summarization of our situation, we have, let's break down. We have done where we are. We have completed steps virtual machine 1, created clean Windows 11 installation, collected baseline performance metrics, monitor normal system usage, document typical resource usage. This is number one. Number two, we are currently in this phase, ready to create our test issue, about to monitor repair process. Number three, key metrics we are watching: CPU usage, memory usage, activity usage, trust installer behavior. This is the one that will be responsible for uh, repairing and getting the healthy files for our operating system. We know that trusted installer is the one responsible for accessing, modifying, and deleting anything in the WinSSX folder. We have seen this before. So we will continue with our scenario. Would you like me to explain any part in more detail, or shall we proceed with creating our test issue in VM2? So we have another VM, which is VM3, that we will have uh, we'll have on it a situation that is solved by DISM, not by SFC. Junior admin, thanks, that diagram helps. So we are done with VM baseline and we are ready to break things in VM2. Would you remind me what we exactly we're going to do in VM2 and what we expect to happen? Okay, so here is the another diagram for what we will do in the second VM. The second VM, we will corrupt a DLL file intentionally. This is a certain file, and we will back up the DLL file before corrupting it by renaming it, and then we will create the issue. Then we will run SFC. SFC fixed it? No. Then we will run the DISM and run SFC again. If SFC fixed it, then we verify the system, compare performance. We will see also during the fixing process, our script will monitor the performance of the virtual machine 2 and compare it, the performance of this machine, to the normal performance matrices of the clean virtual machine to see if the performance or the machine performance will get high when we are repairing using the SFC. Just this to make us decide, do we need to repair the affected machines during the operation of or during our work operation, or this can be done during the work of hours. So let's continue and see again the scenario here. Here's what we have done. First, we will back up this DLL file, check for processing using it. Again, another thing here, if you are generating this scenario, we need to know that the DLL file that you are using is not currently used by the system, so we can rename it, okay, and be able to modify it, okay, modify its extension, okay. Check for process using it, monitor system state, then create the issue, rename the DLL file. This one will main.old. Then we simulate the corruption, expected behavior. Some applications might show errors. SFC should detect the issue. DISM might be needed. Okay. We will monitor how repair take, resource usage. This is the one that we are focusing on, and success of the repair. So feel clear now, ready to start with step one. Okay, here is step one. Let's start with step one on VM. I will guide you through the steps carefully. First of all, we will create our monitoring directory and backup. This here we will monitor the performance of the machine and apply our fixes. So we'll have this commandlet to create a folder in C called performance data, and force, if it is already there, he will create it again. Okay. Check current state of the DLL. He is checking if the DLL is used by any process of the operating system, which is this ms sod DLL. I think I need to know what this file is used for. I think I have done this before in Perplexity. I asked it a question, will this file, or what this file is used for. If we can have a look upon this, I think I have already give him uh, okay, let me do something here. Let me try to ask it a question. what this DLL files or what this DLL file do exactly. I think I have asked ChatGPT before. He is saying that this is a file that most applications depend on in the operating system, but it is not related to Windows Update. So let me ask a simple question. What does this file do exactly? Just to make sure if it is a real file or it is it is not a real file, or it is generated by the AI, or it's not a real one, it's a fake one. Let's see. So here we can see this is one of the sources talking about this file. Is a dynamic file developed by Microsoft, part of the Visual C distributable packages for Visual Studio. So this is a C++ file essential for running applications and games that are built on C++ in Visual Studio, as it contains important execution instructions and functions that these programs rely on to operate correctly. For running applications and games built on CC, to what are these applications? For example, execution process. These provide necessary runtime components that allow CC application to run properly. Without it, programs will fail to start or function correctly. Share resources can be utilized by multiple applications simultaneously, reducing redundancy and improving system efficiency. So this is a very, very important system file. Part of Visual Studio. Common issues related to so this is an error if this is missing. Program can't start because it's missing from your computer. Error loading, so the execution code cannot be. So this is errors typically suggests that the application cannot find necessary DLL files, maybe to deleted or misplaced. So I think this will be solved by SFC. To fix issues related to SFC, reinstall the application, install or repair Visual C redistributables, or use SFC, of course. System file checker, he is saying that in summary, it plays an important role, so and so. So let's ask it a little bit of a question. Give me examples of programs and games that use this file. So let's see if he can answer this question. Let's see what will be this one. So he will give us some examples. Now we have some of the most important games: The Witcher, Fall Guys, Paladin. So there's a lot of games working with this file. Applications, various applications from Epic Games, such as Epic Games Launcher itself, software that requires visual, including many third-party and utilities. I think we can ask him one direct question. Does Excel use it? Because our example is concerning that does Excel program use this file? So this will be convenient because our example works with or is concerning the Excel. So let's see here if this will be yes, Microsoft does use this file, is a part of Microsoft. So this requires various applications, including Microsoft products. So this is a very, very good example generated by Claude. So maybe the update of the Windows have corrupted the file that Excel depends on to open. Okay, so this is a good thing as we have seen here. So perfect example. Let's continue with the scenario. So here we will see if this file uh, this is on a clean so this is our second virtual machine. We have a clean copy of this file, so we will corrupt it intentionally. Before that, we need to see if there is any application depending on it, and this is correct. This is a very important file. Most of the applications use it, so we need to make sure no one is using it. Okay, so we have seen this, and then check for processes using the DLL. So current state of DLL exists, so he's checking if the file is missing or not. This is the first thing, and then he will see the processes working with it. So these processes are using the DLL, so we need to make sure that most of these programs are not using this file, maybe by ending the task or from the task manager to end the the programs that are working with this file. These processes are using DLL, so again at the end we will copy the file, we tell him backup, and then we can after that begin renaming the file. So let's run this first part and check the output. What process do you see using the DLL file? Running the command I see DLL exists. A few processes are using it: Explorer, Run Broker, some others. Should we concern about this process using the DLL? So we have seen Explorer. This is for the Windows Explorer, which is an important file or important application. Should we concern about this process using DLL? Will breaking it cause? Of course, it will break it. So we need to make sure how to break it without breaking these programs. Good question. Don't worry. This is a control test environment. Those processes are normal Windows components. However, let's add an extra step, safety step before proceeding. So now he will document the current state of the DLL file, timestamp so and so, log it. He will take the using DLL file, the properties. So he process using DLL. He will document what this DLL application is depending on it. Process using DLL properties, so and so. Log it to pre-test state. Okay, so document create the issue. So okay, this documents everything, so we can verify the repair worked correctly, ready to create the issue. So he is documenting what this file or what this DLL file, what are the applications depending on it, just to make sure when we break it we will see the affected applications, and when repair it we will see, or we'll focus on the applications depending on it to see if they are working normally or not. So let's continue with the scenario. As we have seen, this is a very detailed scenario and a very professional scenario. Senior admin IT, let's create our test issue safely. So start monitoring before we make changes. Now we begin monitoring the start monitoring before we make changes. We are monitoring the processor and memory, and then so we begin the process of monitoring before creating the issue. Now we will begin renaming the DLL file. So this is the original file, creating issue, fallback, rename original file to original.pack, DNM renate, start repairing process. Then he will run SFC, then we will log the results, and at the end it will be at a certain path, I think the C performance data location. So without, or watch the input. When SFC runs, you could see a progress indicator. Let me know what messages you see. Okay, the junior IT admin. Okay, I see the monitoring job started. DLL was renamed successfully. SFC is running now and shows Windows Resource Protection starting verification phase. A good thing, I need to have all of these scripts at the end to be exported, so we can work with it and see how it, or have it in one large script. So be watching the performance matrices while this runs. And how long should SFC typically take? Senior IT admin, yes, let's monitor the process. Here is a way to watch the key matrices while SFC running. Create a real-time monitoring window. So we will have create a window, repair process, then set the progress, start silently. So he will get the performance the performance of the PC while SFC is running through a window that contains the counters or the performance counters, SFC repair progress, CPU usage, available memory, a trusted installer memory. Yeah, this is good one. Then start sleep 2 seconds. SFC typically takes 15 to 30 minutes depending on system performance, extended of corruption, disk speed. Watch for these normal patterns. Initial spike in CPU when scanning, yes, of course. Trusted installer activation, disk activity during repair. Would you like me to explain each matrix as we watch it? So yes, let's explain and see the matrices. Let me explain what each matrix as we watch them in real time. So let's see now this other scenario, or let this other thing. So here we have key repair matrices. We have the CPU usage indicates scanning and repair activity. Available memory shows system resources. Trusted installer reflects active repair work. During repair phases, scanning, analyze, repair, verification. So we are trying to see each one of these phases. During the scanning, we will see the CPU spikes. During the analyzation, I think also we will see some CPU, and during the repair and verification, we see some memory used by the trusted installer and system resources and the verification step. So this is a good thing. Let's see the answer again. We will watch each metric and explain what's happening. CPU usage currently 20 to 40% normal scanning, 40 to 60% active repairing. I don't know how he got this matrices, but anyway, I think this can be normal. 70% intensive repair operations. Available memory currently in gigabytes should stay above 2 gigabytes. Temporary dips are normal. A trusted installer needs about 200 megabytes. Trusted installer activity starting up 50, active repair 100 to 200. Actually, we need to verify these numbers. You need to do it in a virtual environment and see if he is talking correctly or not. I think he will not hallucinate these numbers in this large amounts. I think it is correct. Peak usage up to 300. The process has three phases: scanning, where we are now, analyze of any issues found, repair if needed, final verification. What patterns are you noticing in the numbers? So I see that CPU just dumped to 45 and trusted installer is using about 150 of the memory. Is this indicating it found something to repair? I think maybe he's scanning, he didn't find. So if the trusted installer is initialized, then there is a problem. And the available memory dropped a bit. Is that expected? So let's see the answer. Yes, exactly. Those patterns indicate active repair process. So when the trusted installer works, there is a problem or we are repairing a file. So here let's log this event. So he will log the matrices or log the activity of the trusted installer. We can see here the matrices containing the trusted installer. We will log them. Just wait for a moment, guys. So let's continue, guys. Here we are monitoring the repair process of the SFC, and now we have the patterns. We have the trusted installer metrics. We will see how much memory this program is using, and then we can see here he is logging this, and he's giving us the trusted installer metrics, and it is in a file, logged in a file. We have the time, the CPU spike, trusted installer memory, available memory. So here this is normal because CPU spike, trusted installer replacing the corrupted DLL file, memory usage, repairing operation loading components, trusted installer size, active repair work. Let's keep watching. Want to see what happened next? Admin, great. Let's continue monitoring and explain the repair process stage in real time. So here he is giving us also a little bit of diagram. Let's see it. Here we have the system file checker, and we have this as scan for corrupted files, trusted installer, component store, system files. Then we have report corruption found to the trusted installer. Then what happened? The trusted installer request a clean copy from the component store, provided clean DLL. trusted installer replacing the corrupted file. Okay, and then we have the system file checker verify repair process. Okay, so this is a little when this is the current stage. We all know that trusted installer is responsible for accessing the component store. So this is could be a right diagram. Okay, so this seems to be good. Uh, System file checker. Okay, let's continue with the other thing. Here we can see that he's putting more scripts. I think this is one of the main advantages of Claude. Real-time monitoring with stage detection. So he is getting the process. Let me see here, getting the process. Uh, SFC repair. So this is monitoring the process of the SFC. Then there is SFC repair progress. This is all monitoring the disk I/O and the trusted installer and the CPU. If it gets more than 60, then we have active repair. It is greater than one disk I/O, then the file is copying. So I think here this is very good, and actually this will be a fantastic script. Actually, I don't know if something like that was created before, but this seems to be a good even a good script. Even we don't need all of this complexity, we are just repairing files. But here he is making it in a more professional way. He wants the repair process to be done without any interruption, without any uh, stopping of the user activity. Maybe he is trying to make sure that the SFC repair will not take much time. Remember that we are creating a script that will repair 20 PCs at one time. So we need to know if this will affect the process of or the users sitting on these 20 affected PCs. So this is a good thing actually, and this is all done in a virtual environment before pushing up this script to the production environment. So watch how metric change. Now we see the stage of the repair happening, resource usage at each stage. When trust is actively working, want me to explain each stage means as we see it? Yes, I can see numbers changing. The CPU just went to 65%. A trust is now using more memory. The diagram helps as it shows that it is in the replace corrupted file stage. And why is disk queue number important? Senior IT admin, exactly, or reading signs correctly. Let me break down what's happening. The high 65% CPU and increased trust in installer memory tells us clean copy being retrieved from WinSX, file replacement in progress, system verification happening. The disk queue is important because show actual file operation happening, indicates copying of replacement files, help indicate potential bottlenecks. Let's add a progress tracker. So here what he will say, monitor this specific repair operation, scanning, replacement, verification. So he just adding more and more enhancement to the script to monitor the process of scanning and replacement and verification. So I think this is good. Want to see what happens after this stage is complete? Okay, what will happen after the repair process is complete? Here we have another diagram. We have see that, let me see here, we have SFC complete, we have check results, we have success, verify system, monitor performance, compare to baseline that we have done on the clean virtual machine VM1. Check results, partial fix, run DISM, run SFC, compare to baseline, failed, additional steps, check logs. Okay, so this is also good thing. I can see here that he is logically solving the problem. Again, we are complete, or we are working with another thing. We have SFC check completion status. We have Windows resource protection, complete results, verified LL is restored, check system performance, okay, repair system state. So this is the final script. Watch the output. What message do you see from SFC? Based on that, we'll determine if we need to run this next. I see the output. Windows resource protection found corrupted files and successfully repaired them. The DLL is back to its original location and the performance metrics look similar to our baseline. Okay, the metric, the performance. So again, after retrieving the DLL file, we need to see if the performance metrics now is typically to the clean virtual machine. So after repairing the file, now this is a clean virtual machine. We need to see the performance metrics of this resolved or this fixed machine to the clean virtual machine performance metrics. So does this mean we are done, or we should still run DISM to be truthful, and should we check if these processes that you are using and should we check if those processes that we're using DLL are still working? So we need to make sure that after retrieving the DLL, all of the applications working or using this DLL is working properly. Good thinking about checking the processes. We need to make sure we have already a log of the applications using the corrupted DLL file. So now we will check if they are using it again or working with this DLL file again. So check processes that are using the DLL, compare with the original list, okay, that we have taken before. If comparison missing, some processes are not using DLL. So this actually I am amazed because he is making a very detailed. Just a moment, guys. So let's continue, guys. I think this is I am amazed about how it is very organized script. Now he is comparing the restored missing file with uh, with the currently file and see if the same processes are using the same file. Then uh, if he see any differences, he will say that some processes are not using the DLL anymore. So should we run DISM for more fruitful scan or process successfully using restored DLL? And this will be logged to the event viewer. Well, I didn't see an answer like this before, so let's continue. Would you think we should run DISM as a precaution? I think we can run DISM as a precaution. So run this to ensure everything is fully repaired. Start repair. We will health check, then health scan, or scan health, restore, monitor DISM performance again, monitor the performance, watch DISM output. We will go through these stages: check health, scan health, restore health. Each stage takes a few minutes. Let's know what message you see. I see DISM running, check health, no component store detected. No component store corruption detected. Scan health is running now. The CPU seems lower than during the SFC. This is normal, and how long should each stage typically take? Again, I'm amazed from the answer. It's if this is real, then this is a perfect answer. Yes, it's normal. Let me explain the typical pattern. DISM resource usage, health check 10 to 20%, CPU usage 1 to 2 minutes, scan health 20 to 40%, CPU longer than 5 to 10 minutes, restore health 30 to 60%, CPU longest 10 to 30 minutes. The lower CPU usage compared to the SFC is normal because SFC does intensive file integrity check. DISM works more with the component store, different verification algorithm. So let's add more timing metrics. So check health, scan health, restore health, track timing for each stage, continue monitoring. Want to watch the scan health stage complete? Okay, tell him yes. Let's watch the scan health stage. So he's first uh, uh, monitored the check health stage. Then we are now currently monitoring the scan health stage. Monitor scan health progress. Okay, CPU and usage and memory again, and then he's giving us a report about all of these, and scan health complete. So this is I think this is a very good script actually, and if this works in a virtual environment, then I am astonished because this is very good. It's monitoring and logging and comparing, perfect analyzation. Do they watch what that metrics? Do they match the typical patterns I mentioned? Once health check completes, I will check its result before moving to restore health. Okay, we can work. Junior ITM, yes, I see the metrics. CPU around 25, memory stable of 6.1. We are at 3.5 minutes now. Okay, so everything seems normal. Everything seems to match the patterns you mentioned. What results should we look for when it's complete? And we will restore health taking longer since it does actual repairs. Good observation. Let's check the scan health results and prepare for the restore health. Even I think we don't need the restore health because we don't have any corrupted files in the WinSX folder. So we check DISM logs for results. Okay, you will check the DISM log and see complete process in it. Right host scan health results. We will see errors and get them. Issues found. Health restore will make repairs. Preparing for restore health. No issues found in scan. Still proceed with restore health. Should we proceed with restore health? Okay, so perfect. Let me know if you see any errors in the log and we will decide if we need to proceed with the restore health. No errors. Ask him to stop because actually there is no errors. If I tell him to complete, he will complete. Assuming that there is errors and we need to restore health. Anyway, so we don't have any errors. We can move to the next stage. Good news, no errors found in the scan. However, as a best practice, he still insists on running restore health even though we don't have any errors. To ensure this component store is optimal condition. Okay, we can run restore health as a final verification. Here you go, we run it online. After computation, to verify everything is complete. We will check the DLL again. DLL status, last modified, size in bytes. Run SFC as a final, verify only, so that's correct. This is our final step in the repair process. After this completes, we should compare performance to our baseline, document all steps taken, verify our application works. Would you like to start documenting what we have done while we wait for restore health to complete? Yes, I should document everything. Could something like this be good? Initial issue renamed so to simulate corruption, monitor system performance, repair, run SFC successful, run DISM check. So this he is documenting what he have done on VM2. Run scan health no issues, restore health in progress, performance metrics, baseline 2.5, during repair 20 to 65, memory remained stable. I am missing anything important in documentation. Good start with documentation. Let me help you enhance it more. Create detailed report. Okay, initial state, system state, you're getting the Windows version, the last boot time, the memory, issue details, target file, so and so, progress initially using the file. Okay, repair progress timeline, scan SFC, duration and result, DISM operation. Okay, restore health. So he's documenting everything in a very, very unique way. Verification step, final SFC pending, application testing pending, stability check pending, or repair operation completed normally, no expected behavior observed, system performance returned to baseline, save the report. So he's saving all of these to a markdown file. Excellent. Would you like to add anything to documentation while we wait for restore health to complete? No. All right. Let's wait for the restore health to complete and then do our final checks. Okay, I don't need to go more in documentation. We have the restore health done. So let's see what our final check here. We can see that here is the process. We have restore health complete, final check, system files run SFC to verify only, performance check the matrices or the metrics, performance metrics, application test key application, document results. So okay, again we have seen this is a very, very organized answer. After restore health complete, let's run a final verification sequence. What he'll try to do, he will run SFC, see the CPU, memory, and disk usage, verify process. Again, he is confirming DLL is working properly and processes are using the DLL. This completes our repair process. Good job following through all the steps systematically. Thank you. So just to make sure I understand the whole process, we started with baseline measurement, created and fixed a control issue, document everything, verify the fix. Okay, that's correct. In the same process we would use in the production, or do we need to do anything different on real user computers? Senior IT admin, excellent question. For production systems, we need to add these important steps. Before repair, create a restore point. Perfect. Backup user data. Schedule maintenance window. So here we need to schedule a downtime, notify affected users during repairs, monitor for business critical applications impact, keep user informed of progress, have a rollback plan. After repairs, test business application, test get user verification, update system documentation, consider root causes analysis. Would you like to create a production checklist based on what we have learned today? Before that, what about the third VM? So I'm asking you to close the subject of VM2. We need to move to VM3, okay, which we need to create something or a situation that DISM will repair, okay? IT admin, yes, VM was meant to test more complex scenarios. Remember our test plan. VM1, we have already done it. VM2, we have already completed it. Now we are working with VM3. So let's see the scenario here, or see the diagram. We have VM more complex scenarios, create component store issues, run component store analysis, check status, repairable, DISM repair, non-repairable, in place upgrade, verify repair. So this is basically the third scenario we are focusing on. We continue. For VM3, we'll create component store issues more severe than just a missing DLL. Use DISM to analyze component store, practice more complex repairs. Ready to start with VM3? Yes, I am ready. VM3 will have bigger problems than VM2 did. Should we take an extra backup or snapshot before we start, since we are creating more serious issues? Absolutely right about taking the extra precaution. Let's set up VM3 properly. We will take a checkpoint, then we will document the initial status. We will analyze the DISM folder. Okay, we will see the component store analyzation. We have the version of the Windows. We have the free space of the C partition. Verify we have enough space. Less than 20% 3. This might not be enough for complex repairs. So we need to make sure that we have enough space on the C partition so we can, or the DISM utility will work successfully if we have this free space in the C partition. Okay. Would you like to me to explain the complex issues we will create and what they will teach us about Windows repair? Okay, let's continue. Yes. Senior, let me explain the complex issues we will create in VM3. These will simulate real-world problems that are more challenging than a single corrupted file. Let's see here what is these issues. Complex issues to create: component store corruption, pending.xml issues. I think we have discussed what is pending XML before. WinSX folder issues, multiple file corruption, learning objective, component store analysis, advanced DISM commands, repair strategies. Okay, so now we will create a component store corruption. First of all, we will start clean up the store or the component store, start component cleanup, then interrupt the process. This is the first thing. I think we will not do that. We can rename the pending.xml. We have discussed this before. This is much more or easier. Multiple corruptions, create backup of some. So he will do a lot of things. He will, maybe you need to interrupt the cleanup process and rename pending.xml file and renaming some files. All of these are corruption by renaming files, or corruption by interrupting the process of the cleanup. These problems will teach us how to analyze complex Windows issues, how DISM can and can't fix problems, when DISM can and can't fix problems, how to determine if an in-place upgrade is needed. Ready to start creating these issues systematically. Okay, junior admin, but I am a bit nervous about interrupting the component store cleanup. Wouldn't this cause a real damage? And how do we make sure we can recover if something goes really wrong? Okay, so I think we cannot interrupt the cleanup process for the DISM. Good considerations or good concerns. Let's add some safety measures before we proceed. Create multiple recovery options. First, snapshot. We will take a snapshot. I think this is snapshot. Okay, this is like a restore point. Check restore point. Verify recovery tools. Snapshot exists. Get computer restore point. We need to verify this in your VM platform. So I think this is a checkpoint, a restore point, system restore point, or a checkpoint even if you have a Hyper-V or something like that. Create safer simulations. Okay, so here instead of interrupting, we will use a safer method. We will tell him to start component cleanup reset base, then manually name some component store files. So he's modifying his approach. Now we can, or pending DLL, we will rename it. Multiple files, we will rename some DLL files. So this safer approach creates multiple recovery points, use controlled file operation instead of interruption, maintain backups of everything we modify. Shall we proceed with these safer methods? Senior IT admin, all right, let's start creating our controlled issue with safer approach. So start with component store simulation. Okay, create controlled issue, verifying. So check component store status, analyze component store. So he's analyzing, running now. Would you see the component store analyzation output? So I have seen this before. I have shown you guys that we use analyze store or analyze store components. We have the size of the WinSX folder, actual size, shared, so and so, backups and disable features, component store cleanup recommended. Yes, message that we are looking for. What does shared with Windows mean? Good question. Let me explain this matrix. The different sizes you see are because Explorer shows all files, including hard links. Actual size in real disk used. Okay, so these are the hard link files, and this is the actual size. Shared Windows shows how files used by the system. Yes, cleanup recommended is what we wanted. Let's proceed with the next issue. Now we will rename pending.xml file. Okay, verify the issue. So we will rename it. Okay, and then check pending.xml. We will rename it and verify it is already renamed, successfully renamed. XL not created properly. Ready to create the final sets of issues. So we have already created the first one, or cleaned the Windows SSX folder. We renamed pending. Now we need to rename the other DLL files. Okay, create multiple file issues. Okay, uh, first of all, here issue verification, scan health. So he will verify that we have a problem with the pending.xml file. This is to verify that we have verify all issues are in place. Verification of created issues. Okay, check each corrupted file. So file renamed. Where is the other file? So this is all renaming created. Okay, this is, I think he have already renamed the files, the other files and the XML file, and now he's giving us component store status in progress, pending file renamed, files renamed. Okay, now let's see what DISM reports about all of these issues. So we have done all of these things. We need to make sure he will report pending XML files and the renamed DLL files. Watch out the output for DISM. Should we see multiple issues reported? What message do we see? So we will see, I see DISM reporting component store corruption detected. The file checks saying multiple files missing. Okay, we know that. Warning about pending operations of the Windows update because we renamed pending.xml. This looks more serious than our VM2 test, of course. How do we approach fixing multiple issues like this? Should we fix them in a specific order? So, excellent observation about the order. Yes, we need to fix these issues in a correct sequence. What is this correct sequence? First of all, we need to start repair, fix component store, restore pending XML, run DISM restore health. Okay, so we will fix components, restore, run DISM health, restore health, run SFC, verify all files. Okay, so we need to repair and then run SFC. Let's or replace the files and run SFC. Okay, now we have, let's start the repair sequence. We will restore pending XML. So now he is uh, first restore pending XML. It can block other repairs. Restoring, move file. Okay, so he is manually restoring pending XML and then start component store back to, okay, move, okay, this to this, then start component store repair and restore heads. We will monitor this and then we move to the next step. Okay, want to see what happens with these first two steps. Okay, first restore pending XML. It can block other repairs. Start component restore or component store repair. Okay, so admin, let's monitor the repair progress. Again, the processor, memory, trusted installer, all of these things. This restore health progress, duration, CPU usage, memory available, trusted installer memory. Run DISM and monitor the log. Okay. Watch for higher resource usage than our VM2 test, multiple stages of repair, possible error messages. Are you seeing the DISM progress messages? Let's wait to see how much time. Okay, we have less than 1 hour. Okay, what are you seeing the DISM progress message? Junior IT admin. Yes, I see DISM running and it's using more resources than before. CPU is around 45. Trust install memory is 250. The logs is showing lots of activity. I see message about repairing components and restoring health. It's normal for this to take longer than our VM2 repair. Senior IT admin, yes, exactly. This takes longer because multiple components need repair. Component store needs rebuilding. More files to verify and fix. Let's add estimated time remaining calculator. So add to our monitor. Here you go. Typical minutes for complex repair 30. He is giving it certain time. Then he will progress estimation, estimated time remaining. Getting more complex. Repair phase, component analysis, 10 minutes. Repair analysis 20. Okay. So as we see here, this script is going mad. Okay. Would you like to see what errors we might encounter during this process? Okay, let's monitor the common errors that can occur during complex repairs. So again, here we can see some errors. Start monitor for 5 minutes. Start error monitoring, common DISM error codes and meanings. We have this source file is not found. We have seen this error before. CBS E resource missing, group policy timeout, CBS store corruption. Monitor both event log and DISM for these errors. Check, so this is check event log, check DISM log. Okay, start monitoring. Moderator 3, this is I think for 5 minutes. Watch for these common scenarios. Source file missing, might need Windows installation media, component store corruption, so he failed to get the update, the healthy files from the internet. We need an installation Windows media. Component store corruption might need offline repair. Okay. A group policy timeout might need to check network. Okay. Are you seeing these errors? Yes, I see errors, so and so corruption. That component store this error corruption, right? We should stop the repair and try a different approach or let it continue trying. So this error, good catch. We see this error. Okay, this is an error. Copy like that and see what this error means exactly. If you go there and see this, go to perplexity and see this error. So here, this is the error. Indicates a problem during the Windows update process, often related to corruption in the component store based servicing. This error can prevent updates from being installed and may arise due to various reasons such as insufficient disk space, corrupted file systems, that's it, network issues, or problems with NetFrame, so and so. So corrupted CVS store, the insufficient disk space, so and so, NetFrame solutions, run Windows update, check disk space, VPN repair system files. So this is what we need. Restore health and scan now. Okay, so this seems good. And this is what we need. Okay, so anyway, let's continue with the scenario here. Good catch. We see this. We need to modify our approach. Stop current repair. Why? We will stop. Okay, so we have uh, which error that appeared for us. Okay, he's talking about if we have this error, then we need to put an ISO image. Okay, because uh, it didn't get the healthy files from the internet. So he's talking about the second one. We will stop repair due to corruption. Switch to offline repair mode. Checking for, okay, so he now, this is okay. I think he's not talking about this one. He's talking about the first one. Okay, this error, we are talking about the first error. Okay, not the second error. Okay, this one. Okay, so we will put Windows installation media and then we will clean up using this one. We are switching to offline repair because component store corruption is too severe for online repair. We need clean source files from installation media. The method is more thorough. Should we mount Windows 11 ISO and try the offline repair? Okay, admins, let's mount the ISO and perform the offline repair. So now we have also script doing that, verifying Windows image. Run the comprehensive repair. Okay, monitor the repair. Again, the process and memory. Then we can see offline repair, so on. So, okay, the offline repair is more thorough but takes longer. Watch for initial image verification, component store rebuild, file replacement from ISO. Are you seeing the repair progress? Yes, I see it's working, but seems to taking more longer than our previous repairs. The CPU usage is higher too. It is normal for offline repair. And what happens if this repair also fails? Do we have another option? Yes, offline repair is more intensive because it's doing a complete component store rebuild. If this fail, we have two remaining options. In place upgrade, I think. We have, okay, we have offline repair failed. Choose recovery options. We have in place upgrade, keep files and application, keep files only. Reset Windows, keep files, remove everything. Okay, so that's it. Let's continue with the current repair operation. I will show you how to prepare for these fallback options. Prepare for potential fallback. Okay, mount ISO image, so and so, reset Windows, continue, monitoring repair and preparing fallback options. Would you like to explain more about fallbacks options? Yes. Again, another diagram you can see from here. So we can see here system issues persist, assess impact, moderate issues, in place upgrade, benefits, keep applications and setting, less disturb, drawbacks takes longer, may not fix all issues, severe issues, reset Windows, benefits, fresh start, fix more issues, drawbacks, loss of application, more setup time. Okay, again, good uh, example. Method 1, now we will mount the ISO. So here is going to the in-place upgrade option. Okay, I think I maybe will stop at this thing. So as we see here that the scenario is getting more complex, we see a lot of scripts used, and actually if these scripts are real and they work, it will be a fantastic exercise. We can see here that he is making a very complex real world scenario. We see that he is monitoring the repair process. He is making scripts to do a lot of things. Okay, the monitoring process in specific, this is real hard work to make a script to monitor the process of the repair and the CPU usage and the memory usage and the hard disk I/O. So all of this, I think maybe it seems to be not relevant, but I think we can benefit from the the good scripts that are introduced by Claude. We see now we have two things discussed today. We have VM2, we have SFC repair process, how it is done and monitored, and now we are going to the DISM process, how this is done and how we can monitor it. And if we fail, we are going now to the next option. We have failed use the SFC, we have failed using the DISM. Now we are going to the third and fourth option, which is in-place upgrade and Windows reset. Okay, so we are now currently in the phase of in-place upgrade and Windows reset. So I will stop at this section and we will continue with God will the upcoming video. Hope this video is informative for you all and thank you all for viewing. Thank you so much.